Hi everybody, welcome to today's video about solving quadratics using completing the square or CTS. I just want to start off with a quick review. We've talked so far about how we can solve quadratics using graphing. Remember, when we graph, the solutions are on the x-axis, and then we also have learned how to solve quadratics using factoring. So now we're going to start a new method, which is called completing the square. And this is basically going to be used if you can't factor or graph easily. All right, so it's kind of an alternative to our first two methods. So before we actually start using this method, we first have to know a couple terms. The first is what we call a perfect square trinomial. And a perfect square trinomial is basically when you have a quadratic with three terms. That's what the trinomial part means. And it can be factored into two identical binomials. So if I have this example, x squared plus 14x plus 49, I could factor this into x plus 7 times x plus 7. And the reason we call it a perfect square trinomial is because there are two of them, so we can write it as x plus 7 squared. Okay, so anytime the factors are the same, you can write it as that factor squared. So we want to be able to take an equation and make it into a perfect square trinomial because it will be a lot easier to work with, to solve, etc. So let's practice just coming up with that last number. I've got the equation x squared plus 10x plus some number, and I want to know what number would have to go there to make it a perfect square trinomial. You could guess and check a whole bunch of numbers, but we've got this one little process that actually makes it really easy. So what you're going to do is take your b value, and remember the b value is always the number in front of x, and you're going to take b divided by 2, and then you're going to square it. Okay, so if I take my b value, that's 10, and I divide it by 2, and then square it, I get 5 squared, which is 25. So to make this a perfect square trinomial, it would have to be x squared plus 10x plus 25. And you could check this by writing or factoring it out. X plus 5 times x plus 5. 5 times 5 is 25, and 5 plus 5 is 10. So it worked out, and 25 was our missing number. And I would encourage you to try this one, x squared minus 16x plus some number. So you would want to figure out what negative 16 divided by 2 squared is. And once you find that number, that's going to go here. Okay, so the same process, b divided by 2, and then square it. This is what would turn a trinomial into a perfect square trinomial. And this process is what's going to lead us into completing the square. So we would use completing the square for basically two different scenarios. The first one would be if you want to convert your equation from standard form into vertex form. And then the second one would be if you were solving an equation that could not be factored. Okay, so we're going to start off by just practicing converting the equations from standard form to vertex form, and then we'll get into the solving. So I have the equation y equals x squared plus 6x plus 8, and I want you to change it into vertex form. So if you remember, vertex form is in the form a times x minus h squared plus k. And remember, your vertex is at the point h comma k, and this should be on the board. So we want to convert it from standard form into this form. To do that, we're going to follow some basic steps. I'll write these down. The first step is to move the c value to the other side. Okay, so we're going to move the c value to the other side. So I'll do that here. So step 1. So if I subtract 8 over to the other side, I'm going to get y minus 8 equals x squared plus 6x. Okay, so that's step 1. Step 2 is to complete the square. So just like what we were practicing in the last slide, I want to figure out what value will go at the end of this equation to make this factorable on the right side. So to do this, what we're going to do is take that b value, divide by 2, and then square it. Okay, so we have y minus 8 equals x squared plus 6x, and I'm looking for the last number. Okay, so what we do here is take 6, since that's our b value, remember a, b, and c, so 6 divided by 2, which is 3, and then square that, we get 9. So we're going to put a plus 9 here. Okay, now part of completing the square is that you keep your equation balanced. So if I add a 9 on the right side, that means I also have to add a 9 on the left side. Okay, so that's very important. So completing the square, figure out that y value or that value at the end, and then make sure you add it to both sides. So when I simplify, I'd get y plus 1 equals x squared plus 6x plus 9. And by doing this, now the right side of my equation should be factorable. So that's where we're going to get into step 3, where it says to factor. Okay, so step 3. So we're going to have y plus 1 equals, if I factor the right side, I'd get x plus 3 times x plus 3. And then I can go ahead and rewrite this as y plus 1 equals x plus 3 squared, because they're identical, so there's 2 of them. And then remember the last step, we want it to be in this form y equals, so all I have to do is subtract my 1 over to the other side. And when I do that, I get x plus 3 squared minus 1. And there's my final equation. So now it's in vertex form. Remember, I started in standard. Now I have vertex form, and you could use this to help you graph. I would be able to identify the vertex from this equation. I could find my axis of symmetry very quickly. Very useful to have it in that vertex form. Go ahead and try this example down on the bottom on your own, and if you'd like me to check your work in class, feel free. I just want you to convert the equation y equals x squared minus 16x plus 2 into vertex form. So follow the same 3 steps, moving the c value over to the other side, completing the square using b over 2 squared, and then factoring at the end.